Hello everyone, today we are going to present about the binary search algorithm and selection sorting. Our group name is Katie Ben and here are our group members and we all are from session 4. Now let's start our presentation. First of all, let's begin with the binary search algorithm. Binary search is defined as a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. In binary search algorithm, we have to choose the element in the middle of the array and compare it against the search value. If the element and the search value are matched, we are then here. And if the element is greater than the value, we have to search the left half of the array, and otherwise we have to search the right half of the array. So this concept of binary search algorithm divides the array into half, and so its time complexity can be presented as O log n. So the binary search algorithm can be used in real-life programs when we want to find a word in a physical dictionary where the words are sorted alphabetically, and when we want to search a file in a computer where the files are arranged in a certain criteria like names and size. So the next slides will be, next slides. Next is conditions for when to apply the binary search in a data structure. The first one is that binary search typically works well with the data structure that allows for efficient random access to elements like arrays and certain types of lists because they provide constant time access to elements by index. And the second is the data structure must be sorted. So how to implement the binary search algorithm? There are two ways to implement the binary search algorithm, and the first one is iterative binary search algorithm, where a set of instructions are repeated in a sequence until the specific condition is met. It typically uses looping constructions like for loops, while loops, and do while loops to execute a block of code repeatedly. And the second one is recursive binary search algorithm, which is a method that solves a problem by calling itself one or more times to solve smaller instances of same problem. It breaks down the problem into smaller subproblems and solves each subproblems recursively and finally combines the solution to obtain the final result. And the next part will be presented by Lisa.
Hello, I'm Desatun, and I will explain about the advantages and disadvantages of binary search. For the first time, advantages of binary search are binary search is faster than linear search, especially for large arrays, more efficient than other searching algorithms with a similar time complexity, such as interpolation search or exponential search. The next thing is binary search is well suited for searching large data sets that are stored in external memory, such as on a hard drive or in the iCloud or on in the cloud data. Like for another thing is disadvantages of binary search. The array should be sorted and we need to sort the array first, and binary search require that the data structure being searched be sorted in contiguous memory locations. Binary search requires that the elements of the array be comparable, meaning that they must be able to be ordered. For the next thing I will explain is about the applications of binary search. Our first thing is binary search can be used as a building block for more complex algorithms used in machine learning, such as algorithms for training neural networks or finding the optimal hyperparameters for a model. It can be used for searching in computer graphics, such as algorithms for ray tracing or texture mapping. It can be used for searching a database. So the next slide will be explained by Duncan as well.
Okay, hello, I'm Kanyazo. Okay, now we have listened the theory explained, so let's move on to the example. This is the example about the irritated binary search algorithm examples. This code implement the binary search algorithm to find the index of the given element in a sorted array. For the class binary search, and this method take two parameters: the array to search index array, in the index array, and the element to find x. The initialize two pointers L and R, representing the leftmost and the rightmost index of the array. It then enters the while loop that continue until and L is less than or equal to R. Inside the loop, it calculate the middle index M and check if the element S array M is equal to X. If it is return the index M, if X is greater than the middle element, it average to L to M plus 1, ignoring the left half of the array. Otherwise, it average L to N minus 1, ignoring the right half of the array. If the element is not found after the loop exits, it return minus 1. For about the main method, this is the entry point of the program. It creates the instance of the binary search glad. Then if define an array and initialize it with sorted integer. It specifies the value x to find search for, and it's called the binary search method with array and x add argument and store the result in the result variable. If the result is -1, it prints that the element is not present in the array. Otherwise, it prints the index where the element is found. So the output for this code is element present at index 3. Next slide, please. Okay, this slide is about the recursive binary search algorithm example. And in this code, implement the binary search algorithm recursively to find the index of the given element in a sorted array. And this method take 4 parameters. And for parameter, the array to search and the leftmost index, the rightmost index R, and the element to find X. It first checks if R is greater than or equal to L, including that array is not empty. Inside the method, it calculates the middle or the index mid. If the element at array mid is equal to 8, it returns mid. If less than the element at mid, it recursively call binary search with L mid -1 and X searching only the left sub-array. If 8 is greater than the element at mid, it recursively call binary search with mid 1, R, and X searching only the right sub-array. If the element is not found after the recursive call, it returns -1. For the main method, this is the entry point of the program. Is create the instance of the binary search class. Then it define an array and initialize it with sorted integer. It specifies the value x to search for, and it's called binary search method with array or array 0s, initial left index, and -1 as initial right index, and x at argument, and store the result in the result variable. If result is -1, it prints that the element is not present in the array. Otherwise, it prints and the index where the element is found. So the output for the code is element is present at index 3. And next slide will be explained by Kaimo.
Hello, I'm Ki Mo, and now I'm going to explain to you what selection sorting is. Selection sort is a simple and efficient sorting algorithm that works by repeatedly selecting the smallest or largest element from the unsorted portions of the list and moving it to the sorted portions of the list. This algorithm repeatedly selects the smallest or largest element from the unsorted portions of the list and swap it with the first element of the unsorted part. This process is repeated for the remaining unsorted portions until the entire list is sorted. So why do we use selection sorting? Because it is a basic sorting algorithm that is easy to understand and implement. Also, selection sorting has various real-world application, especially in scenario where simplicity is preferred over performance, or the dataset is relatively small. Here's some real-world example. First, arranging a group of people in ascending order based on their height, or organizing file in a directory by their creation date or site. and sorting a list of students by their grades or name in a small class. Next slide, please. In this slide, I will compare the advantages and disadvantages of selection sorting. First, selection sorter is simple and easy to understand and also work well with small data set. But there are some drawbacks of using selection sorting as it has a time complexity of O(n) squared in the worst and average case. Selection sorting does not work well on large data set and does not preserve the relative order of items with equal keys, which means it is not stable. The next slide will be presented by Tongkat.
Hello, I'm Tonga and I will explain the rest of the slide. The selection sort algorithm works in a very simple way. It maintains two subarrays for the given array. The subarray is already sorted, and the second subarray is unsorted. Next slide. In the example, there are three methods: print array method, sort method, and main method. Print array method prints the elements of the array. Sort method implements the selection sort algorithm. Main method initializes an array, creates an instance of selection sort to sort it, and prints the sorted array. And I will briefly explain how the sort method works. First, we need to declare a method named sort that takes an array of integers as a parameter. This method will sort the array using the selection sort algorithm. Line 7 declares an integer variable and assigns it the length of the array R. At line 10, we start a for loop that iterates over the elements of the array, except for the last element. It initializes an integer variable I to 0 and continues looping until I is less than and minus 1. It increments I by 1 in each iteration. At line 13, we need to declare an integer variable main IDX and initialize it with the current index I. This variable will store the index of the minimum element in the unsorted part of the array. At line 14, there is a nested for loop that iterates over the elements of the array, starting from the elements after the current index I and continues until the end of the array. It initializes an integer variable j to I plus 1 and continues looping until j is less than and it increments j by 1 in each iteration. At line 15, if the element at index j is less than one element as index main IDX, that element will be smaller than the current minimum element in the array. At line 20, the block of code swaps the current element at index I with the minimum element found in the unsorted part of the array, main IDX. This step ensures that the smaller element is moved to its correct position in the sorted part of the array. This is the end of our presentation, and thank you for your attention.